So it's often useful to describe motion or represent motion in terms of a graph. It's just kind of easier to see what's going on in a quick snapshot rather than maybe a data table with a bunch of position and time values. So we typically put position on the vertical axis and time on the horizontal axis, just so that we're consistent and always on the same page. Here I've got a little applet. It's made by our good friends at FET at Colorado University, and this particular app is called Moving Man. So you have this guy here and you can just move him back and forth, and here it's going to make a graph of his location or position at different times. So if we hit play here, it's going to start graphing. He's not moving, so he's still at 0. Now if I start moving him this way a bit, and I'll try to have it pretty constant velocity, but maybe won't succeed. Well, that's good enough. Alright, so what do we see here? Again, as I mentioned, when you're not moving, your position is constant as time changes, so you're going to have a horizontal line. Here I was moving to the right, so I get a positive slope to my line because my position is increasing with time. If I move to the left, I get a negative slope. Here I kind of messed up and was stationary again, then kept moving to the left, right, and all that. So the slope here represents the velocity of the object. If I've got a positive slope, it means I'm moving in the positive direction, and same with negative, means I'm moving in the negative direction. In this case, that's left and right, but you can define positive and negative however you like, as long as one direction has one sign, the other is opposite. The other feature of these graphs is here I've got a pretty steep slope, right, and here I had a pretty shallow slope. This means my position was changing quickly in a short amount of time. Here my position didn't change very much in a long time, so this means that I was moving slower, and this means that I was moving faster. Another feature is right here. We are crossing the origin, and that location really has no significance. Because I went from positive values to negative values, that doesn't mean I changed direction. It just means I crossed over that location that I called 0. But I could call any location 0. I could have called this location way over here 0. That wouldn't have changed the shape of my graph at all. So crossing that line of the origin really doesn't have much physical significance. Alright, I'll have a link to this so you guys can play with it a bit if you want in the description under the video in YouTube. One other applet I wanted to show you briefly. This one, here's the URL, but again I'll put that link down later. You might have to, it's kind of an older website, so you might have to put this, change your Java settings so that it allows this website. This one does show velocity and acceleration graphs. I'm not going to talk about acceleration yet because we're just dealing with constant velocity, which means things are not accelerating. But in addition to position graphs, we can have velocity graphs. And so here's what those are going to look like. If I start out here at location of 20, I guess it's aligned with the front of the car, and I'm moving 5 meters per second, and if I say that my velocity is constant, that means I'm going to be moving 5 meters per second the entire time. So just a car cruising along, you got cruise control on here. So if we go back here and look, we've got a nice linear positive slope, and our velocity graph is constant. So I've got a horizontal velocity graph when I have a constant slope on my position graph. Now if we go back here, if I have a different velocity, say we go up to 10 meters per second, well, all that's going to change is I'm going to have a steeper slope here, still going to be a horizontal line here, but now it's at 10 instead of 5. If we start over here, say at 40, we can have negative velocities, and so we're just going to be heading in the other direction. I've got a negative slope, I've got a negative constant horizontal line here. I do cross over the origin, which is when the car goes bye-bye, but again, that doesn't have any significance physically. I'm still moving at a constant velocity. For those of you who've had some calculus or are familiar with it, even if you haven't taken the class, the velocity is the slope of this line, or the velocity is the derivative. I guess that's the calculus part. But we can see right here we've got a rise of negative 40 over a run of 8. So negative 40 over 8 is negative 5. So that's how you can go from this graph to that graph. Another interesting point is if you find the area of this graph, the area between this line and the x-axis. So again, let's just go to 8 seconds because we know what happened here at 8 seconds. So if I take the area of that, negative 5 times 8, that's going to have an area of 40. Well, that's my displacement. It's negative 40 actually, so I went from 40 down to 0 in those 8 seconds. Again, I'll put this link and you guys can play with this a little bit. See you next time.